So the problem here is to use trigonometry to solve for the missing side in angles. So if you notice, I'm given side CB is a length of 9. Side AB gives me a length of 41. I am missing length AC, which will be called side B. And I'm missing two angles, angle A and angle B. So to use trig, we remember SOHCAHTOA. That just helps me remember sine, cosine, tangent. So if I look at angle A, I have angle A right here. If I look at angle A, I look, well, what do I know about angle A? I know the opposite side length, and I know the hypotenuse side length. Therefore, I would have to use sine. So sine of A would be opposite over hypotenuse. Now to actually get into that angle, to find actually angle A, we have to use the sine inverse. So I type that into my calculator. Sine inverse is just above sine. 9 over 41 gives me 12.7 degrees. And it is important that you check to make sure you're in degree mode. So just to double check, we were in degree. We were in degree mode because we were looking for a degree of an angle. So good. We're good on that. We found sine of A to be 12.7 degrees. Now I also need to find angle B. So what do I know in relationship to angle B? I know the adjacent side and I know the hypotenuse side. Adjacent and hypotenuse would be cosine. So cosine of B would be adjacent over hypotenuse. Again, to find the actual angle measure, I have to take the cosine inverse. And if I type that in, I get the angle to be 77.3 degrees. Good. Now, I ended up using trig to solve both of those, but you know, if I already knew angle A, remember from geometry class, I could use the triangle sum because I know that all three angles in a triangle add up to 180. So if I know one angle is 90, I take that from 180, and if I knew the other angle was 12.7, I should get that the third angle should be 77.3 by triangle sum. But since this problem asks us to solve it by using trigonometry, I got the same answer using my trig. Either way works, just as a matter of how they want you to solve it. So the last side is B. Now again, we could think back to Algebra 1 class and geometry, and we know the Pythagorean Theorem. So if I know two sides of a right triangle, I can find the third side. So we'll solve it both ways, using trig and using the Pythagorean Theorem. So here I have 9 squared plus B squared equals 41 squared. I am missing the length of a leg. I have a hypotenuse. So 9 squared is 81. 41 squared is 1681. Subtract 81 from both sides, and B squared equals 1600. Take the square root of both sides to get B alone, and B gives me 40. B gives me 40. So let's make sure using trig, though, I can still get B to be 40 units. So here's B, and we do know we just solved for A and B. So let's just go ahead and use angle B to be 77.3. So I could say B, little b, side AC, is opposite angle B. So opposite, and I could use the hypotenuse, so I could say the sine of 77.3 is equal to opposite over hypotenuse. And so really all I have to do is multiply both sides by 41. 41 times the sine of 77.3 to solve for B. So what I'm going to do, I'm going to do that, but I really want to get exactly what sine of 77.3. So I'm going to go back first and retype in cosine inverse of 9 over 41, because that gave me the 77.31961651 and give me all the decimals. We never want to round to the very last step, so I want to use that. So I want to find the sine now of that number, so sine of our last answer, and we're going to multiply that by 41 to get B, and there it is. So we multiply both sides by 41, so B equals 40 units. And I solved all parts of my triangle. I now know the two angles that were missing and the missing side.